A warm welcome to you from the Ravin Group. Established in the year 1950, the Ravin Group operates in 5 verticals: manufacturing energy cables and supplying cable solutions up to 220 kilovolts, EHV installations and services up to 400 kilovolts, manufacturing specialized power equipments, customized solar EPC solutions with tracker systems. The group has gone on from strength to strength and has its presence with clients spread over more than 50 countries around the world. We manufacture various types of cables: LT, HT, power, control, specialty, etc. The construction and design of the cable determines how efficiently the cable will perform under all sets of circumstances. Ravin Group holds proud record of not having a single reported cable failure due to manufacturing or design defect. There are various kinds of conductors: solid, stranded, and flexible conductors, depending on usage and areas of application. For the same electrical cross-section, a solid conductor would be 15% lesser in diameter than a concentric round conductor without any compression. A lower diameter cable is easier to handle on site and facilitates larger drum lengths. The conductor design plays a very important role in the performance and the losses in the cable. These ridges pose problems in the functioning of the cable. Sharp edges not only damage the insulation but also cause excessive capacitance and increase transmission losses. Smooth conductors reduce transmission losses by 3 to 9%. Compaction plays an important role in reducing conductor resistance. Air gaps in the conductor not only increase conductor resistance but can also lead to accumulation of moisture. Conductor design and number of strands play a very important role in determining the life of the cable and the losses in transmission of electricity. A bad cable can cost you very heavily in terms of excess power consumption. If we take an example of a 70 square mm conductor design with a 2.24 mm wire diameter, a construction of 19 wires is recommended. Simple geometry tells us that if we are to completely cover the central wire, we will need 6 wires of the same diameter. Similarly, to cover 6 wires, we will need 12 wires of the same diameter. We then hence have a 1 plus 6 plus 12 construction. This would be a good construction. This drawing shows why for a 70 mm square cable, the ideal number of wires is 19. Thus, a conductor with 19 strands would be a smooth conductor and would give trouble-free service. A conductor with lesser number of strands would not be smooth and would leave gaps or ridges. The kind of fillers used in the manufacturing of the cables can enhance or reduce the performance of the cable. The filler needs to not only protect the cores but also give circular shape to the cable. PP fillers are the best material for filling the interstices of the cable, be it circular or sector-shaped cores. PVC fillers are cheaper and can harm the cables. Let us see why. Reprocessed PVC fillers are the worst damagers to the performance of the HT cables. There are various limitations in the PVC fillers and they act as an easy passage of water and other liquids during operation. The PVC emits fumes which permeates to the XLPE insulation and degrades it. Discoloration and degradation of the XLP occurs on contact with fumes from PVC fillers. There are various advantages of PP fillers, like it is lighter in weight, flexible in nature, occupies space between the cores and does not allow passage for water, and has a better temperature compatibility with XLPE insulation. It enhances the electrical performance of the cable. Incorrect handling of drums during unloading laying can cause damage to the cable. If unwound incorrectly, it can damage the cable armor and consequently the cable. IS 1255 gives in great detail the methodology for laying cables as well as the precautions to be taken while laying the cable. Excessive bending, pulling forces damage the cable prior to it being put into service. bending radii, and pulling tensions, norms are to be followed for proper installation. This prevents any damage to the cable before being put into service. The use of frequency control for motor operations is on the increase. Motor speeds need to be finely controlled for optimizing the output. This allows for saving in power usage for motors. Such frequency control requires a great deal of caution in cable design and selection. The ultimate benefit is reduced power bills. The output waveform sometimes creates a standing waveform and can damage the motor and its bearings. It is hence essential to control the amplitude of the output waveform. The effect of higher frequency has various detrimental effects on the electrical installation, including the cables, motors, and electronic equipments. In a standard multi-core cable, each phase conductor induces a voltage on the ground wire. There is a flux generated by each core on the ground wire. All three phase conductors are 120 degrees out of phase with each other, as are the induced voltages. If we add up three sine waves of equal amplitude that are 120 degrees out of phase, the result is zero. The induced voltages on the three ground wires are not equal in amplitude, but 120 degrees out of phase. Adding up these voltages result in a significant voltage on this ground conductor. Since the ground is a part of a circuit, these induced voltages can have detrimental effect on motor bearings. Various designs were tried to minimize the effect of the induced voltages. Traditionally, a cable with three phase and three ground conductors were used. Even in this case, the sum of the induced voltages was close to zero, but not zero, a marked improvement from the earlier design of cables. In an effort to make the sum of induced voltages to zero, we use our expertise and have formulated special designs. A properly designed cable helps in many ways, limiting risk of failure and saving on power consumption. One advantage of the Ravin Speicalty cable is that it minimizes ground currents in the system. Ground currents have been shown to cause bearing flooding, which may cause premature motor failure. If we look at a truly symmetrically designed cable, all the induced voltages have equal amplitude and are 120 degree out of phase with each other. These cancel out each other and the induced voltage in the ground conductor is truly zero. This cancellation of individual induced voltages are due to the symmetry of the cable. Another Speicalty cable addresses the concern of loss of life in case of fires. Today we have many skyscrapers and towers. In case of fire, it should be possible to evacuate people in a safe and timely manner with least damages. Traditionally, PVC sheathed cables have been used in indoor applications also. In the event of a fire, the PVC burns furiously, releasing large quantity of smoke and chlorine in the air. The smoke reduces visibility to low levels and makes it difficult for movement of firefighters and people. The chlorine gas, when it comes in contact with water, dissolves to form concentrated hydrochloric acid that damages the electronics and all other equipments in that area. With the National Building Code requiring fire safety systems to be operational for 120 to 180 minutes, we need to have some mode of transmitting power that allows fire elevators to work, allows sprinklers to function. The cable should also release little or no smoke that will enable easy movement of firemen and people. Such a solution is in the Ravin fire survival cables that are subject to stringent testing and conduct electricity for 2 hours in a raging fire and helping save lives. Depending on the kind of structure and the application, there are various categories of fire survival cable which are put to use, from 650 degrees to 950 degrees. The equipment shown is capable of testing fire survival cable for a period of 3 hours. A stitch in time saves 9. Our next Speicalty cable changes colors in case of overload. Overloading a cable causes the cable to heat up. Such heating can be uncontrolled and cause fires in the cable. The Ravin color changing wire will change color when overloaded and overheated, giving a visual indication of impending trouble. This allows advance action and corrective measures to be taken and averts any tragedy. To illustrate the color change, we have two identical wires being dipped in hot water and cold water simultaneously. The wire in hot water changes color instantaneously. This wire, when dipped in cold water, reverts to its original color.